I'm an ex-solo founder of IndiePaper, the startup on which this talk is based on. This talk is actually based on my experience trying out different tech stacks for building this set startup and finally ending up on Phoenix LiveView, and how I actually kind of fell in love with it. And so that's it. I'm currently working as a consultant in a company called Lascade, where we're building out their internal reporting systems for Aswin and all using Phoenix and LiveView. I was previously working as a mobile developer at Buy Me a Coffee, and I'm a mobile turned full stack developer. So before we start, happy 10-year anniversary, everyone. Happy 10-year anniversary, Elixir. I've been doing Elixir for like 1.52 years. So it's great to see that it's been 10 years. Okay, so let's talk about IndiePaper. IndiePaper is a platform for authors, self-published authors, to write their books in an online editor. And when they're done with it, just hit publish, and we will typeset it. We'll create the PDF. We'll make it readable online, and we'll send it to printers to print out and send to your readers. So it's a complete end-to-end integrated platform for authors. So that was IndiePaper, and I'll just show a demo of it. So if let's say you're an author, you can just create a new book, and when you're done with the book, you can actually publish it, and we will render out PDF and of the set manuscript. So that was the entire product of the startup. So next, choosing a tech stack for your startup can be hard. I went through the same phase. I started working on this in May 2021. I had no idea what tech stack to base this on, and I rewrote it a couple of times before I actually came across Phoenix LiveView, fell in love, and IndiePaper's final production version is actually written in Phoenix LiveView. So this talk is about that experience. Okay, tech stacks can be two types. There's front-end heavy tech stacks and back-end heavy tech stacks. So what front-end heavy stacks do is that they produce single-page apps. Front-end heavy tech stacks. Okay. When I started IndiePaper, I started with a front-end heavy tech stack. A front-end heavy tech stack is like when you have a single-page app, and that runs in the front end, and it connects to a hosted database or a host backend as a service apps like Hasura, Firebase, MongoDB, or Superbase. And the first initial version of IndiePaper was actually written as a front-end heavy app. The advantages of writing your startup in a front-end heavy app is super fast user experience. Nothing compares to the performance of a well-written SPA. And new frameworks actually make it really easy to create performant SPAs. This is actually just the landing page of this, and the blog is written in Next.js, which is a React-based framework. So you can see that it loads on this click. This does not even, we can even disable the cache and it would still have that performance. So that's unbeatable in a single-page app. Second is high interactivity. You can have sliders, you can have different things, you can have things moving around, you can have animations, and those are all possible in single-page apps. Second, the next part is it's easy to get started. Since you're only concerned about the front end of things, it's really easy to get started writing front-end heavy apps. And since it is easy to get started, the community is actually really big. You have more packages. Take React, for example, you have more packages, more developers, and more tutorials for starting with it. And since a single page app is basically just a bunch of JavaScript and HTML files, you can zip it up and host in multiple regions. And that actually helps in getting more performance. Disadvantages, it's JavaScript heavy. The users have to download a bunch of JavaScript. You have to execute the downloaded JavaScript. The second is wiring of data sources. Since front-end apps actually execute on the front end, they have to communicate to the backend over a network connection. Network fails, networks takes times, and that causes a kind of loading and bad user experience in that sense. And second, since we are handling everything by ourselves, there's a bigger surface area for errors. And since single-page apps actually take over the platform, they take over the back button, they take over the scroll, we have to make sure that we are taking care of these things. And single-page apps, they're not that great for single SEO, since JavaScript needs to be executed for content to come there. Then comes host backends. hosted backends are like they take backends and they create a platform in front of the platform, in front of the backend. So it's like things like Firebase, Superbase, which is actually a sponsor and it's built on Elixir Phoenix. And yeah, so their advantage is they're easy to get started with. Everything is well integrated. Everything is everything is well integrated, like file handling, authentication, authorization. Everything is built into the hosted backend, and they have SDKs to connect with front-end frameworks, and they provide an easy API for data manipulation and fetching. But the disadvantages are there's vendor lock-in, and most of these have request-based pricing. So that means when your, let's say, your app scales out, it gets really expensive really fast. Then the capabilities are really hard to extend. So if the hosted backend doesn't do what you want it to do, it's really hard to extend it. You either have to wait for them to implement this, or you have to cobble together different services and make it by yourself. The next thing is it's hard to develop locally, because since these are by default hosted on the cloud, local development is an afterthought. So that's an issue. Then there's hard to test, which is like, since they're in the cloud, your tests are going to go over the networks too. And since they have to develop locally, the testing scene is not that great either. Then I actually implemented Next.js using all these using IndiePaper, using Next.js and this backend platforms. And I didn't kind of like it because of mostly the offline and the testing phase. And I wanted something that was more extensible, that was easier to work with and develop locally. So I looked into Backend Heavy apps. What Backend Heavy apps does is that rather than the business logic and the code living on the client, we write it and the business logic lives on a server. The user asks for an HTML as with the request. The request comes to the server takes it everything up and processes it and creates an HTML page and returns it to the user. So that means business logic and everything relies and lives on the server. Advantages. Comparing to front-end heavy apps and single-page apps, you don't need to wire up data. Since the data is locally available in the server, it's just you can actually directly substitute that value in your templates. It works with the platform. Because the web was developed with this model in mind, everything actually helps. The platform makes the user experience of this request response cycle really easy. Offline and local development, since this backend heavy apps need to be developed on our own machine, the offline and local development scene is really nice. It's extendable because they're low level and they're easily testable because they're mostly running offline in your machine. Disadvantages. In 2022, even though most people won't care that your app is either a server-side rendered or a client-side rendered one, it still pales in comparison to a client-side server run. The snappiness is just unmatched. The snappiness is unmatched. Second is security. Since you're hosting your own backend, that means you're responsible for security. With hosted backends, what that means is they have security teams working there to make sure that the security is up and running, and we have to deploy and maintain the server side by ourselves. So I rewrote it in Ruby on Rails. This Ruby on Rails, this version was actually the first MVP that I showed to anyone else. So the advantages of, I actually had experience with Rails shipping 1 or 2 production apps. And it's the most bang for lines code framework I have ever seen. You write 10 lines and you can actually have a completely complete file server up and running. It's that amount of abstraction it sits on top of. So it's like limited amount of code and you can have a lot of things. And I actually shipped one app in one night. I coded it in one night and I shipped it in the next morning. It's because of Ruby's that thing. This is just the most productive framework out there. The most productive framework. Second is magic everywhere. Everything about Ruby and Rails is magic. It's like everything you touch, every gem, everything is magic. So it's like, it actually comes back to the first point, which is like for a very small amount of code and work, we can do a lot of things. And since Ruby and Rails has been around for a long time, it has a really big community, which means more tutorials, more books, and more things. So disadvantages. While I was working on this, I felt the framework kind of being heavy. It's like a feeling like when you start a truck, you feel the heavy engine running, you feel the heavy oil just circulating everywhere. You can feel the big tires. So it's like it's heavy every time you start the server, every time you start, you reload, you refresh, you can see a slight delay and you can feel the heavy framework running underneath. Second is magic is everywhere. Magic is good when you're going the way magic wants, but if you want to slightly extend it, or when you want to just take a slight deviation, what happens is this magic actually becomes a bad thing, because then you have to actually pop open the hood and look inside it to see how to figure out how the magic is happening, and then you have to extend it. That was an issue because bugs, and some bugs were hard to trace down in the Rails app. And there are major breaking changes, not so major, but in major in asset handling and all, which caused me to waste some time there. And I never felt kind of liking Ruby, because Ruby has no constraints. It's like whatever we try to write, if it's as close to English or something, Ruby tries its best to compile it. So it's like Ruby has no constraint. It wants to be as close to English as possible. And it contributes to the slowness of Rails. It's fast enough, but not fast, really fast. And it's craft. It's been around for a long time. So there are things in the framework that kind of don't make sense anymore. Then I came to Elixir Phoenix. I heard about Elixir Phoenix for a while, and I really wanted to try that out. So I popped up in some tutorials, bought some books, and started writing. And Elixir Phoenix was actually the final thing that I stuck with. I spent almost 6 months in development. It was final production version. There are over 12,000 commits. It went through the production and Hacker News launched. 200 plus others signed up and connected with this Stripe account, and 10 plus books were published. And it was the real most fun that I ever had programmed when I had ever programming. Yeah. And I asked myself why, mostly for the stock. Then I figured out that startups are fundamentally business problems. I was in a hole for the first 3 to 4 months, trying out different frameworks and trying out different tech things. And I came to the realization that you won't get any awards for your tech if it doesn't solve a business problem. So startups are fundamentally business problems. You want tech that solves that problem. I figured that out after wasting 5-6 months on those different things. So what we want in a startup is simple, sharp, pragmatic tools. You want it to be simple enough so that you're not fighting complexity in your apps, and you want it to be sharp so that whatever thing you want to do, you are able to do it. And Elixir and Phoenix are the most pragmatic tools that I've ever used. It's like everything in an Elixir and a Phoenix is built to have things done by people. And I think it comes from being the creators, both Jose and Chris, being hardcore programmers and not language designers first. They wanted to do some things, and so they made Elixir. And Chris wanted to do concurrent processing, and that's why he made Phoenix. So that kind of translates down to this Elixir and Phoenix being really pragmatic, strong foundations. Elixir and Phoenix is actually built on Beam and Erlang. Beam has been around for a very long time. They have started with managing telephone switches, and Erlang has been around for that long. And rather than throwing out everything, Elixir is a thin layer on top of Erlang, and Phoenix is a thin layer on top of Elixir. So that means we get the underlying foundation, which is really strong and is really battle proven, almost for free. The best thing I write when I'm writing, I like when I'm writing Elixir and Phoenix apps, this documentation is a first-class citizen. It's like, let's say, docs. Every package in Elixir actually has consistent documentation. That's the thing that I like most about it. Everything is consistent because documentation is actually built into the language. So this can easily be generated from the language itself. So that means every package in existence for Elixir actually has this consistent documentation structure. We have guides, we have modules, and you can actually go there, which means that when you're introduced to a library, even though the amount of documentation might not be that much, you can figure out where the documentation is really fast. And the best thing about this is documentation as being a first-class citizen is that in your editor, you can actually see the documentation if your editor supports it. So that means while coding, rather than going to Google and searching for it, you can just find the documentation from your editor itself. This is really fun when you're programming, because when you're at the crust of solving a problem, you don't want to leave your editor and go search on some place. Second is tests. Elixir is not strongly typed, so that means we need tests. But unlike other languages where tests are an afterthought, in Elixir, tests are built in. Everything from gen servers, from context to databases, everything has its own, everything can be tested, and Elixir has its own testing framework called Aswin. So that when you do test-driven development in Elixir, it kind of meshes into a really fun, really great way to work, because since tests are a first-class citizen of Elixir, what that does is that you can test everything. You can test the features. So while I was writing IndiePaper, I would just start with writing a feature test. I would go with Author can connect their payment systems, and I would write a feature test Author can connect payments type. I would write this first, and then I would run this, and this would fail, and then I would go to the router, and then the test would tell us what happened, why this test failed, and then we will go to the router, we will add that, and we'll add more components and go from there. And then we run this again. Then it says we don't have the controller defined. We define the controller, run this again. And every step of the way, we are actually writing code that satisfies this test. And after we finished, we have a complete test suite that tests the feature that we have worked on right now. And I kind of understand that in the startup world, there is a common misconception that test kind of slows you down. But what I learned from working on IndiePaper is that after a while, if you have a good enough test suite, not even 100% covered test suite, but a good enough test suite, what that helps is that it makes you confident enough to change your code fast. I would implement a feature in IndiePaper. I would write this in the test-driven way. Then I would run the entire test suite, and I would find out that there are some bugs that I introduced without knowing in some other parts of the code. I would fix that, and I would add tests for that. And what that does is that the next time I want to make a change, I'm confident that every other thing will be automatically tested by this. And that kind of increases the velocity of your startup as you go. And that's really one of the nice things about Elixir and Phoenix is the tests are fast because Elixir is a concurrent language by default. Every test is fast because it executes everything executes at a time. Okay, so this is you either let it test your customers test your app, and one of them, yeah, it's you don't want customers looking at your app and be like, hey, this is breaking all the time. With a consistent enough test suite, you can actually convert them into happy customers fast. The next thing is pattern matching in pipes. It's a syntactical sugar for Elixir, but still it kind of meshes really well with how the entire Elixir and Phoenix app is structured. The first principles of Elixir development is that you have a big struct that holds the entire data that you want, and you make it flow through different functions that accept this struct and return the struct, modifying the struct along the way. That's like the Zen of Elixir. I found out that I kind of think is the Zen of Elixir. So just look at this test. This session actually opens up a Chrome headless browser to test it. And this function takes in a session and it changes and it adds to the session to visit that page, and then returns the same session. And then this function takes it this session and it fills the form with the email and password, and it passes it down and down and down. And this actually meshes really, and this is like the way that most Elixir code is structured. And pipes is a great syntactical sugar which enables this. Without pipes, I don't think this would be this pretty to look at. And the second is pattern matching. In IndiePaper, we actually have a text editor, which you can type your text in and you can click publish, and we will take that text and we will convert that into a PDF through LaTeX. So in the typesetting engine, the typesetting engine is actually written like this. We have a JSON that represents the entire text the author has written, and we take it and we call this function on each part of the text. And rather than a big, huge case statement, we have functions that pattern match on the structure of the data. So this means that one, this is really fast because these pattern matches are actually compiled into the code. Second, we don't have to handle a lot of error cases because we can have a catch-all statement under here. So that's what pattern matching does. It is another way of writing code, and it's really, really fun to figure out the correct patterns and just match on them, and things started magically happening. Okay, so complex things are simple. In Elixir and Phoenix, let's say you want to do job processing. We have UBAN, and to run UBAN, you don't need anything else rather than Elixir and Phoenix. But at the same time, Rails has Sidekick, which needs Redis, which is another dependency that needs to be hosted somewhere. So what Elixir and Phoenix does is that it has a lot of primitives such as gen servers and actors and all. And what that does is that it helps building complex features like this really easy. We can have presence, we have channels, and all these are natively built into Phoenix and Elixir. That means you don't have to reach externally for tools as much as you do in other programming languages. Performance, Elixir is fast. It's not super fast, as much as fast for number crunching, but it's fast enough for pragmatic things like for web development. You open up a server, it's fast. You run your test suite, it's fast. And you can actually see response times under 1 millisecond. And this high level of performance is one of the issues, is one of the main reasons why we can make LiveView possible. Everything is explicit. This is also one of the most, but the thing that I like most about Phoenix and LiveView. Everything is explicit. Everything is on the surface. Everything is actually stares back at you. So let's say I want to see what the fields of an author are. If you do the same thing in, let's say, Rails, all this is hidden. It won't show to you at all, except if you use the annotate gen. So what in Elixir, if you open a model, these fields won't be even there. It's all kept and tracked internally. What Elixir and Phoenix does is that it puts it right there. It's right there in front of you. There is no magic. It's not hidden under anything, and it's right there, just staring back at you. What this explicitness does is that if you want to change something, it's right there. You just have to change it right there. But in the case of Rails, you have to pop open the hood. You have to see how the magic happens and then change it. So this actually helps us a lot of things, because if you want to extend it, if you want to change something, we can change it really easy. And this is actually followed everywhere. So even in the router, where we can see, let's say I just want to see how the sign-up request comes to me and which all functions edited in the way. I have seen that there's a browser, there's a redirect, there's an authentication element, so I just don't understand where the browser is coming from. I go there and here is the browser. Everything is explicit and everything is right there. Second, Elixir is stable, according to Jose. So that means there aren't going to be any breaking changes coming in the language anytime soon. So what that gives is that it lets people have less package managers. In other let's take other languages, for example, one that changes all the time. So let's say JavaScript. Community is filled with frameworks that move at the speed of light. They move, and if they want something, they break backwards compatibility. So what that does is that package managers and developers have to be constantly on the treadmill, adapting to these things, changing the API, changing the internal API, and in the 6 to 7 months there will be a constant flux where packages won't be as stable as we want to be, because package managers are only slightly updating to the newer version. With a stable enough core that actually frees up the package managers and developers to do things that bring value to business. Second is the next is consensus. The entire community of Elixir and Phoenix early on actually converged in a couple of well-tested great libraries. You don't have to search. You don't have analysis paralysis. I mean, when you're working with JavaScript, you have to search for which is a good backend library. Then you have to search and find out which is the great database access library, and which library to use in the front end, which library to use the state. So what that is, there is no consensus. But in Elixir, early on, let's say, what is the best way to build a web framework in Elixir? So that's Phoenix was the best database access library for Elixir. It's Ecto. So it's like, what's the testing framework for Elixir? It's XUnit. And what's the way to generate documentation? It's Xdoc. So the community actually converged on a bunch of well-tested, well-developed frameworks and packages early on, so that they are the standard for doing things in Elixir. And this actually maps back to the backend design. We do not spend a lot of time finding out if this library is good, if this library is maintained, because for whatever you want to do, there will be one which has the majority of the community support. And it's kind of nice to just select that one. The community. Elixir and Phoenix community is actually the sweetest community I have ever seen. I just browse around the forums for a while, and everyone is so nice to each other. If somebody asks a question that would be solved with a single Google search, there are people who answer that question. And if some questions require deep introspection that people take a lot of time to, there are also people there that take the time out of their lives to answer that question. And I'm not saying that there aren't bad people out there, that there aren't, let's say, people who commit bad things, but still the entire community as a whole is sweet and nice and caring towards each other. And I think it stems from Jose and Chris and the entire Elixir core team, because I have not seen any one of them even reply to comments that might anger some ordinary people. They comment really sweetly and nicely and really professionally. And that's what fosters a really great community. And yeah, I'm grateful to be a part of it. Then Elixir is constantly improving. Just in the last 6 months, we got LiveBook, which is a phenomenal piece of software that I used to introspect IndiePaper while it was running. Then we got Explorer, Axon, we got Scenic, and we got Nerves and all in way back, but we got all this, and Elixir is constantly improving. It's constantly new updates are coming out, and a few features and new things are happening in the ecosystem. And it's really exciting. There are books, there are articles, there are more people coming into the community. It's really nice. And Elixir is going to run everywhere. Elixir wants to run everywhere. We have Nerves, which run it on Internet of Things. We have Phoenix, which runs it everywhere, web. And with the recent live data announcement, I'm pretty sure we will have Elixir Phoenix LiveView running mobile apps in less than 6 months. So it's like learning Elixir actually tough, because whatever you do, you're pretty sure that if you want to move into someplace else, there is a well-tested path that Elixir has for you. But I wasn't still happy, because even though I had this much stellar development experience, the user experience was still kind of because Even with Elixir and Phoenix, the user still had to do a full page reload to get the data, to get the HTML, to see the HTML. So that's, I'm not saying that that's a complete deal breaker, but when you compare it to your competitors, you don't want to give them that edge. Like their app is a single page app, it loads quick, it moves fast, and we need to do a single full page reload to even show errors on forms. So that's a really bad user experience. So what I wanted was the developer experience of Heavy Backend, the great testability, the ability to run it locally, and with the user experience of a Heavy front end. It's like people navigate fast. We got better interactivity and everything, and without the heaviness of the front end, because I don't want to spend time writing a heavy front end and wiring this up to a heavy backend such as Phoenix. That's when I came across Phoenix LiveView. What Phoenix LiveView does is that a request comes to the server processes that request, and it sends an HTML. And rather than cutting off the response there, what it does is it opens the persistent WebSocket connection between the server and our client. And for every subsequent request, rather than sending the entire HTML page, what it does is it calculates the difference between what we have on the client and what we need to send, and sends the difference. And JavaScript written by the LiveView team takes that difference and it computes where the difference needs to go, and it kind of mutates the HTML in place to give us an XPA-like experience in just like 1/10 of the effort, because we are actually just doing all the things that we love to do on the server, and we just send it, and we just send it in a view like we always used to do, and Phoenix LiveView is handling everything else. So in that case, when I rewrote it in, so this is a development version of IndiePaper that's running on another server in the United States. And this is entirely written in Phoenix LiveView. So every transaction, every click actually happens through the WebSocket. So let's open the network tab. And first, the HTML gets rendered. Then a persistent WebSocket connection is opened. So for every subsequent thing, rather than reloading the entire thing, what it does is it sends the data through this persistent WebSocket connection, and Phoenix LiveView captures the difference and pre-processes. So what that does is that it gives us a really great user experience with the same really nice developer experience that we used to. And it handles everything. We just need to specify the data right there, and we can have validations, and we can actually have validations like can't be blank, just right there. And this was actually kind of really nice, because now they have the peace of mind knowing that in roughly 1/10 of the effort and a really fun programming language and really fun framework, I can actually compete really well with my competitors. So that's what Elixir Phoenix actually gives you. It gives you a single page like app without going through all the bad things about caching, about fetching, and everything else. But I wasn't still sure, because Phoenix LiveView, when I started, was not that mature. So I had a lot of questions. Will it be performant enough for users? So you can actually see that there is a slight delay, right? When you click and this thing happens. But just remember that the server for this is actually sitting in the United States. So if you're from the United States, you would have a better, more streamlined view. So I'm in India, I'm in Kerala, and even with that much difference and that much round trip time, you still get a decent enough experience with Phoenix LiveView. And I tested it with the different regions, and I was convinced that it is performant. It's more than performant for users, unless and until you're doing mutating work that mutates the UI. So it's like you click a model and it takes, and you're sending a request to LiveView to do that. That might seem slow, but for forms filling, for file uploads, and for day-to-day navigation, it's more than performant enough for our users. If you want more performance, the great team at Flight.io is actually building the best platform to host LiveView apps. It takes a LiveView app, it packages up into Docker container, and it hosts it in different multi-region multi-regionally across the globe. So there is a database, there is a data center actually in Chennai. I'm in India. So if I wanted, I could host my app in those 16 different locations. And if the user actually comes from, let's say, India, the app serves from Chennai. So that means the round trip times are reduced and you get even more performance. And so the next thing is, since JavaScript handles navigations, what if I want to execute custom JavaScript? Those of you who have written Rails apps know during the time of Turbo, what that does is custom JavaScript, you have to wrap it in something else. Otherwise, it won't execute because since we are actually changing this thing through JavaScript, other JavaScript on the page might not execute. So I was actually worried about that. But JavaScript, because the editor had actually a lot of JavaScript code. The editor, this is the editor that users write their text in, and they send that to compile. And this is actually written using a lot. The entire editor is a TipTap. It's called a TipTap editor. It's a JavaScript package, and these are all JavaScript interactions. And Elixir and Phoenix LiveView has a really great abstraction for it called hooks, JavaScript hooks. So what hooks does is it lets you hook into the lifecycle events of the LiveView. So it's like when it's connected, when it's updated, and when it's changed, what JavaScript code do you want to execute? So in the draft editor, I set this hook to execute. And when the LiveView is mounted, we create a draft editor from the package by importing it. And for each and every update, we take the content of the editor and we push it up into our server. So that's solved. Even before this entire thing was actually a Vue app inside a Vanilla Pheonix app. And this current version is actually built on Phoenix LiveView, and every keystroke is actually persisted in our database, and we can is automatically saved. And when you click publish, the entire thing is taken up and compiled into a PDF by Elixir itself. So that issue is actually solved too. With hooks, you can create as many complex things in JavaScript land as you want. What about testing? So I thought, well, since LiveView is actually doing things along the wire and with WebSockets, what does that do with testing? Turns out, testing LiveView is 10 times faster, 10 times easier, and 10 times more stable than testing dead views. So, okay, IndiePaper feature tests were written using the Chrome headless driver, which using Wallaby. So what that does is that it spins up a Chrome driver, and then the testing page is actually rendered into the Chrome driver, and it actually goes through that. But the problem with that is the tests are really, really flaky, which means the Chrome driver might not start up due to memory issues. The Chrome driver might not have a connect to network. And when that happens, the entire test suite fails, and you get bad feedback, especially because you're going there, you're testing this, and you can't trust the test, and you have to trust your test, otherwise you're not going to care about them. So what LiveView does is that rather than opening up a browser and making it click, what LiveView does is that it opens up a gen server and it mounts the LiveView internally in its server. So there is no need to open a browser or a full-scale browser. Each and every click is actually sent to the server, which does the processing and sends it back. So I'm just going to show you the demo. This is actually the app that I'm working on right now. So yeah, it's not finished yet, but still, this is how so this is how you test LiveView. You write this and you go to which route you want to test, and then LiveView returns the mounted view. So this is actually running. So this is actually running in a server, and it returns back that, and along that, uh, then we say find the element, then click that element and follow the redirect. This is all done without even bringing up a browser. So that means tests execute really fast. Tests are not at all flaky, and yeah, that's it. And since this executes really fast, you can run the entire test suite every time you make a change, and it still executes fast enough to give you instant feedback. So the testing was actually one of the best things that I saw in LiveView, because now I can run the entire test suite every time I make a change. When I was developing IndiePaper, some of the tests were actually written in Wallaby and some of it were written in LiveView. So that kind of had that issues. But now we can write the entire thing from integration test to from feature test to integration test to small unit test, everything in Elixir, and it executes super fast. What about connection drops? So that's another issue. What about connection drops? So LiveView relies on persistent WebSocket connections. So what happens when the connection goes out? That was an issue when LiveView actually started out, but with new additions to it. So let's say your user is filling out a form and the connection drops in the middle of the user goes through a tunnel and the connection drops in the middle of it. What LiveView does is that if you have a validate callback in your LiveView form set, it will send that form data that is on the client. The data will be on the client, and it will send that, and then it will merge with the data in the LiveView. So even if the database, even if the LiveView gets the connection gets stopped in the middle, you can actually restore, and it actually restores it automatically. So that's not an issue. What about community? LiveView, everybody loves for LiveView. There are books written programming LiveView. It's a great book that I learned a lot from. There's Testing LiveView, which is another course by Jama Velasco, which I learned how to test LiveView thoroughly. There are articles being written, there are videos. Most of the everyone who used LiveView actually kind of loved it, and we have seen alternatives to LiveView pop up in other packages and other libraries and other things like Livewire for Laravel. We got Turbo for Rails, and Phoenix LiveView. The Phoenix world has actually moved to LiveView. You can find a bunch of articles, you can find videos, and you can find books, and you can find everything to learn how to do LiveView on the internet as soon. So you can do it right now. But it's not all roses and sunshine. Even though I love Elixir and Phoenix really, really well, and I use it every chance I get, there are still some issues with it. Even though IndiePaper didn't actually make it to a stage where I had to hire someone else, with personal experience and with talking to people in my community, the hiring pool for Elixir developers is really, really small. Not really, really small, but really small. It's growing, but it's still small. What that does, so if you're looking to hire a bunch of Elixir developers, you're gonna have a hard time. But at the same time, even though the hiring pool is really small, it's really high quality. There's a lot more concentration of senior developers, and there's a lot more of people who are passionate about programming. So the hiring pool is high quality, lower number. And this might change soon, because Elixir as a community and as an ecosystem is actually growing at a tremendous pace. You can actually see it by the amount of blog posts and Hacker News posts that are coming up. Types. I kind of like strongly typed languages. I've been learning a little Haskell, and when you're writing Haskell, what it gives you is that while you're writing it, the types kind of guide you, like test guide you. Types say that, hey, you're missing this return statement, or you're missing the case when null is happening. And that kind of thing, introspection can only happen in a strongly typed language. But in ElixirConf, our ElixirConf keynote, Jose actually cleared up a lot of things, and he said the agenda for types being worked on Elixir. So I'm fingers crossed on how that turns out. I'm just going to wrap this up. Choosing a test stack for your startup. Remember, startups are a business problem. Whatever you choose, make sure that it is capable of solving that business problem. And then there's first mile and marathon advantage, which is like choose tech stacks which help you in the long term. Don't go chasing things that promise you the world at the beginning and then becomes hard to maintain and after that. So I choose Elixir Phoenix and LiveView. I chose it and I was really happy with it. And these are some resources that you can use to learn with it. I highly recommend that you learn to read designing Phoenix apps with OTP when you're working on large scale systems. Yeah, that's it. It was great talking with you guys. Thank you.